Mr. True, in this video I want to talk about the 6 rules for finding derivatives of trig functions and memorizing them. Through your study of calculus, I'm sure you're going to be, like my students, given a long list of rules for finding derivatives, and ultimately we'll be talking about integration fairly soon, that you'll have to memorize to be successful on your tests, and certainly if you're going to take the AP exam as well. And I'm quizzing my students right now on their memorization of the 6 trig rules for finding derivatives. And they're doing fine, but I'm a little bit worried at the end of the year when they have a whole list of rules to have memorized. What happens when the nerves get to you on the test? And you think, okay, well, I know the derivative of sine is cosine, and the derivative of cosine is negative sine of x, assuming we're not, needing the chain rule. And you get to a problem and you have to find, let's say, the derivative of tangent with respect to x. So the derivative with respect to x of the tangent of x. Well, right now we're just talking doing a lot of work with, again, these derivatives of with these trig functions, and we know right away that that is equal to secant squared x. But, okay, it's a little bit farther down the road in the class, maybe a couple months down the road. We're doing a lot of other things, and we get to a problem, and we're just not quite sure. Was that secant squared, or was it cosecant squared, or something else? Well, kind of like when we did our trig proofs in pre-calculus, sometimes we just need to go back to the parent functions. Our sine and cosine functions basically build the other 4 trig functions. So I can rewrite this as the derivative with respect to x of sine of x over cosine of x. And then, walk through or go through the quotient rule of finding this derivative. And that's going to be the denominator times the derivative of the numerator, and the derivative of sine is cosine, minus the numerator times the derivative of the denominator, which is going to be derivative of cosine with respect to x of cosine of x is negative sine x, all over the denominator squared, which you can write as cosine x squared, or you can write cosine squared of x. Either way you write that, it's equivalent statements. Though I am finding that my students are remembering the chain rule, working through the chain rule more accurately when they write cosine squared of x with that power of 2 on the outside. At any rate, cosine times cosine is cosine squared. Negative times negative is positive. And then that's over again that denominator of cosine squared x. Now, sine squared plus cosine squared, that's one of our 3 Pythagorean identities for trig functions, and that's equal to 1. And 1 over cosine squared is secant squared. And okay, yes, obviously a lot quicker if you just remember that the derivative with respect to x of the tangent of x is secant squared x. But, sometimes our nerves get to us on our tests, and there's plenty of other things we have to have memorized. If that slips your mind, you can, again, write your tangent function in terms of sine and cosine, go through the quotient rule, and double check that your memory serves you right, and the derivative, again, of tangent is secant squared x. And of course, we can do that same kind of work through the cotangent function, but I'm not going to show you that again, right? It's just going to be the quotient rule again. How about if you need to find the derivative with respect to x of, not equals to, but of secant of x? I don't know why I'm wrapping this in parentheses, don't really need that there. But actually, I do often like to wrap the angle that the trig function is being applied to in parentheses. So either way, derivative with respect to x of secant of x. Well, do we remember what that is? If not, we can rewrite this as 1 over cosine. So the derivative with respect to x of 1 over cosine of x, and we can use the quotient rule again to find the derivative of this, or we can write it with a bring the cosine out of the denominator and write it with an exponent of negative 1. So the derivative with respect to x of cosine of x to the negative 1. And now I'm bringing that cosine up out of the denominator, and I'm just going to wrap the entire cosine function in parentheses and put the -1 out front because I see my students, finding that, again, they use the chain rule more correctly when they wrap the trig function in a whole, the whole trig function in a set of parentheses. And I can write this as, cosine to the -1 of x, but again, learning from how my students are seeing this. And it kind of looks like maybe you can even wrap that in a set of parentheses as well if it's bothering you, that we're finding the derivative with respect to x of all of this, and then the cosine has that exponent of -1. And now I'm just going to use the general power rule, or the chain rule, to work this problem out. So we have, bring the exponent down, negative cosine of x, and of course when I'm doing the general power rule, I bring this exponent down, and I can write just a negative sign, or you can write -1 here. Reduce the exponent by 1, and now we're going to multiply by the derivative, again with respect to x, of the inside function. See, the cosine of x is the inside function of this power of -1. So, times the derivative of cosine of x, that inside function. Okay, well now this is going to become a couple of things. I'm going to go ahead and I'm going to take this cosine of x to the -2, or this cosine of the -2 power x, and bring it to the denominator. And we're going to just go ahead and leave this negative up here for a second. That might very well cancel out, maybe. The derivative of cosine is negative sine. And indeed, we have a negative coming in. Again, the derivative of cosine is negative sine x, and we have a negative out here in the beginning of the problem, and those are going to cancel out. And now we have sine over cosine squared. Well, that doesn't seem to remember what I remember the derivative with respect to x of secant of x is, so let's write it like this. Okay, so we have sine over cosine is equal to tangent. And if I show this multiplication of 1 up here, we have 1 over cosine is equal to secant. So if you had forgotten, the derivative with respect to x of secant of x is equal to secant x tangent x, or tangent x times secant x, however it's written in your textbook. And again, this is longer than it would have taken if you just had memorized that, but if you forget, if you're not quite sure, go into terms of sine or cosine in this particular problem. Walk through the derivative process. In this case, again, I wrote that with a negative exponent, went through the general power rule, the chain rule, and got our final answer and derived the derivative rule on my own. And you can do this with the other two trig functions. I'm going to go ahead and step off now. I'm going to show you those two other derivative rules just for the heck of it. We'll call this video done. And here are your 6 rules for finding derivatives of trig functions. And by the way, if you're going to go through the trouble of memorizing them and, if need be, deriving your own rules, make sure you copy your answer down correctly. I did eventually catch the fact that I forgot that was secant squared and just wrote secant. So, I'm Mr. Troop. Go do your homework.